So the same thing is true for the tangent squared of theta minus 1 equals secant squared, and the other one, the last Pythagorean theorem we had was 1 plus cotangent squared theta. So again, you are allowed to solve the original Pythagorean identity, which are in yellow, to any one of the other two things that you need. For instance, the last one, 1 plus cotangent squared theta equals cosecant squared theta. You can solve it for 1, which is equal to cosecant squared theta minus cotangent theta, or you can solve it for cotangent squared theta. They're both valid, and we're going to use them today. So it's a good idea just to add those to your toolkits. You want to add all those on. Does that make sense to everyone? Yeah. Okay. It's a straightforward idea, but I wasn't sure that you were allowed that you knew that you were allowed to do that, so I wanted to say that yes, you're allowed to do that. All right, then I'm going to show you 3 examples, and we're going to talk about the tricks that can be used to get those identities to be established, and review all those, okay? And these are all solid blue squares. So here's the first example that you want to have somewhere in your notes, okay? It says the cosecant, and look, there's a 4 there, power of 4. So cosecant of the fourth of theta minus cosecant squared of theta equals cotangent of the fourth theta plus cotangent squared of theta. Okay, so let's talk about, for just a second, what do you think makes this a challenging problem? What makes this a blue square? Okay, Olivia said the fact that there's a 4th power in there. That's true, but there's something else that is the thing. Ethan, what do you see? There you go. Yeah, both sides are equally challenging, right? Look at both sides. It's kind of hard to say, well, which side do you start on, right? Now, whenever you can't make a decision as to which side you should start on, I always just default with starting on the left. If either side doesn't look easier than the other, if they both look equally difficult, I just default to the left, okay? So I'm going to start on the left-hand side on this thing. So I'm going to make a little note here. Let's start on the left-hand side. Okay, now, here's the tricks. There's a couple of tricks in here. I said we're going to factor, we're going to do 2 switches, and then distribute, okay? So let me show you what I mean by that. On the left-hand side, do you see anything that can be factored from the left? A cosecant squared, you're exactly right. So I can have a cosecant squared theta. I can factor it out, and that will give me cosecant squared theta minus 1. And the reason that is true is because I have cosecant squared times cosecant squared is cosecant to the fourth. Cosecant squared times -1 is a negative cosecant squared. Did everyone see that part first? Okay? That is the factoring part. Then I'm going to do 2 switches here. Anybody using your toolkit, anybody see any switches that we can make? Keeping in mind we're trying to achieve cotangents. Olivia, what do you got? Yes, all of this stuff, yes. Cosecant squared theta. This stuff is cotangent squared of theta. So that's the first switch that we made. Anybody see another switch that we can make? Look at the other one. Cosecant squared, what is that going to be? We just wrote it down, right? Up at the top? Yeah, cosecant squared is equal to 1 plus cotangent squared. It's that Pythagorean identity. So this part can be 1 plus cotangent squared theta times cotangent squared theta. And of course, all this still equals. All right, anybody see it yet? If you distribute, which is the third thing that we're going to do, we did the switch, now we're going to distribute. If we're going to distribute this piece into each of our binomial here, we're going to have cotangent squared theta plus cotangent to the fourth of theta equals, hey, the exact same thing on the right-hand side. All right. The second example says it's 1 minus the quantity sine squared theta over 1 minus cosine theta equals negative cosine theta. All right. So which side do you think you want to start on? Definitely the left-hand side. There's definitely more stuff going on. Okay, so keeping that in mind, I want the left-hand side to be all what? What trig function? All cosines, right? Because that's what the right-hand side is. So I'm going to change that sine squared into cosine. So what do I do to change that to sine squared? Yeah, you got it. So that's going to be 1 minus cosine squared theta, all divided by 1 minus cosine theta. Correct? You guys got that? All right, good. Now at least I have everything in cosines. Okay, now I want to bring up the idea of remembering how to factor the difference of two squares. Anybody see the difference of two squares anywhere? Yeah, this right here is the difference of two squares, right? This is like saying, this is like 1 minus x squared. That's the same thing as 1 squared minus x squared, which is 1 minus x times 1 plus x. Remember our algebra? So instead of x's, I'm going to replace it with what? Cosines. Yeah, you got it. So that's going to be 1 minus 1 plus cosine theta times 1 minus cosine theta. On the desk over there. Thank you. Okay, in my denominator, I have 1 minus cosine theta, don't I? All right. Anybody see anything beautiful that can help us out? Yeah, Ethan, what do you got, dude? 1 minus cosine, 1 minus cosine. Good. That leaves me with 1 minus the quantity 1 plus cosine theta. So if I distribute my 1, I get 1, or excuse me, distribute my negative 1, I get 1 minus cosine theta, which of course is just cosine theta, negative, sorry, which is exactly what the right hand side. So in this one, either side looks the same. Yeah, you can give it to her. Either side looks the same. There's not much you can do, so we're going to default to the left-hand side and start working with that. All right? And the trick on this one is looking at the denominator of the right-hand side. And you see that the denominator of the right-hand side I highlighted for you is cosecant theta minus plus 1. That's what I'm going to choose to multiply and make a fancy 1 out of for the right-hand side. And this is what I mean. I'm going to have this cosecant theta plus 1 over cosecant theta plus 1. That is just going to be my fancy 1. Okay, I'm going to multiply that by cosecant theta minus 1 over cotan theta, and that's going to equal the right-hand side. Okay, so check it out. What does the numerator become? Cosecant squared theta minus 1. That's the difference of two squares again, right? And on the bottom, I have cosecant theta plus 1 times the cotangent of theta. All right? Anybody see anything on the numerator? What would that be? No. What's cosecant squared theta minus 1? Cotangent squared of theta, all divided by cosecant theta plus 1 times cotangent of theta. Okay, this right here changed to that because it's a Pythagorean identity. Okay, now, remember back in algebra, if you had x squared over, I don't know, something, times x, how do you simplify that? That's right, you get rid of the x on the bottom and the square on the top. That's the exact same thing that happens here. Get rid of the squared, get rid of the cotangent. So that means that all you have left is cotangent theta divided by cosecant theta plus 1, which is exactly what the right-hand side is supposed to be.